Mathematics, Ordinary Level, Paper 2, 2021. Now, before we're going to start the question paper, let's just go through the instructions and the information to the candidates. It's very important that you read thoroughly through this page. Okay, so candidates answer on the question paper in the spaces provided. Please don't ask for any extra paper. You write everything on this question paper. If the space is not enough, you can look at the back. As I see it's page 20, there's an extra page. Then you can just mark it nicely, the number, and just make a cross, say, page 20, and go and find the extra space there. Okay. So write your candidate number, candidate center, as well as the name in the space. So basically, just make sure you fill in this correctly. Very important. Okay. Write in dark blue or black pen only. You can use a pencil, a soft pencil, for any diagrams or graphs. I'm just going to say a few things to you that stands in the report. Okay. In connection with the pencil. Candidates should be discouraged from writing in pencil. That means doing the methods or the sums in pencil. You can use it for graphs, except when drawing, and should avoid rewriting over numbers as it makes it difficult to read those numbers. So don't scratch and write another number over the other number. And then candidates should be encouraged to remove eraser deposits from the question. So just clean it with your hand a little bit, doing this to get rid of that eraser deposits. Okay. Very important. Do not use correction fluid. No Tipp-Ex. Okay. But I want to say this also in the report. When candidates abandon their working and decide to start afresh, they are advised to clearly draw a line across the abandoned work. So just draw a line like this through the work. Don't scratch it. Okay, that's not good. Just draw one line. If they leave the old working together with the new working side by side, this is regarded as a choice. And the work that is first seen, so the one, say, on the left-hand side, because that would be the one first seen. Okay, I just want to get my pen. The left-hand side maybe will be marked and not the right-hand side. Okay, so please scratch the one that you don't want so that they can focus on that one. Candidates should be discouraged from answering the question in 2 or more different ways. So don't do 2 methods. Please choose one and keep to that method. In that case, the first method is marked even though it might be wrong. So sometimes you do it if it's not giving you the same answer, it shows one method is definitely going to be wrong. Okay, so I just wanted to say this. Then do not write in the margin for the examination. So it's there. So please don't go over that line. That's for the examiners to write their marks in. Okay. Now answer all questions. If working is needed for any question, it must be below or where working is indicated. Otherwise, go make a nice star and say page 20 or something like that, the extra page. Okay. The number of marks is given in brackets of each question or part question. So just check. That gives you an indication of how much working is required. Non-programmable calculators can be used. Okay. Struggle to see with this. Okay. Now, if the degree of accuracy is not specified in the question and if the answer is not exact, now I said it in all the papers, what does exact mean? It means it stops. Okay. So it means if you say have 2,135, then don't make it 3, leave it 2,135. So otherwise you give the answer correct to 3 significant figures. And if it's an angle, to 1 decimal place. Okay, can I just say something that's also in the report? Most candidates were unable to round off their final answers to 3 significant. So please go and practice that. or to the required degree of accuracy in some questions. So if the question says two significant figures, then you go with what the question is saying. If it says nothing, you go to three significant figures or angles, one decimal place. But candidates are still encouraged to write the full calculator display. So write everything that's on the calculator, not in the space, just after you're working, before attempting to round off the required degree, before you write it in the space to three significant. And even when I'm working, and I'm going to focus a little bit more today on this, when I'm working it out, so I'm so used to not writing and just go to the three significant figures, but it can maybe score you a mark. It's not to say, I cannot tell. So, however, candidates are advised not to round off their answers for questions on limits of accuracy. Very important. I'm going to try to say it again when I come to that question. They should then always, in the answer space, write their full calculator display. Okay, very important. And then I just want to say also in the report, candidates should be encouraged to plot points clearly. Plot all the points. If you don't plot all the points, you're going to lose a mark. Before you join the points when answering the question, or before you draw the curve or something between them, in order to gain the plotting marks. Okay. And then I say, for pi, either use the calculator, the pi on the calculator, or 3,142. Then I just want to say also something that's on the report for this question paper, topics that require more attention. So you must know everything, go through all the topics, but then spend a little bit more time on these topics. Set language and notation. It's chapter 2 in my textbook. Coordinate geometry, I think it's chapter 7. Trigonometry, that's chapter 9. It's in part 2. Area, especially the area of a triangle, the sine and the cosine rule. It's really not difficult. Go just spend a bit more time on that. And then algebraic manipulation, it's usually where algebraic fractions, all that things, just spend time on, and I think it's in chapter 3, it's expressions. And then applications of fractions and directed numbers. So where they bring in practical examples. Okay, with respect to algebra. So where especially when you have to express it in terms of A or B or X. And then the last chapter, chapter 12, statistics and probability. So I know it's a long year, but it was 2 years. You spent grade 10 on it, you spent grade 11 on it. And it's almost like you see the end now, you see the light in the tunnel. So just put in more hours, leave everything, leave the social media, leave everything. And just for this time, towards the end of the year, just put all your energy in preparation for your final grade 11 examination. It's really going to open doors for you in the future. Okay. With all that said, I'm ready to start with question 1. Let's start with question 1. Let's start with question number 1. State if the answer to each of the following numbers and expressions is rational or irrational. So the best will be if I first take you to the textbook and let me just revise what is rational and what is irrational. So if I go to the textbook, we go and check at question 1, where it is the first page in part 1, grade 10, 11, mathematics, y equals mx plus c. Okay, now there is the different numbers that you know. So this is real imaginary. That's school mathematics, and that is not school if you go further in maths. This is rational numbers, irrational numbers. Now, rational numbers, now I can even make it still bigger. Okay, there it is. Now, rational numbers can be written as a vulgar fraction. It means if you get 2.8, then you can write 2 and 8 over 10, and you can simplify it. If you have 2, 5, 6, 8, and it stops, so it's -3, then it's 2, 5, 6, 8, and how many? And then I put it over 4 zeros. 1, 2, 3, 4. Because 1, 2, 3, 4. There was just 1. Even if it's recurring, because if I have, say, the number 0. Let's say 7. Okay. Now, although it's 777, but because it's the same number that's repeating, you can test 0/7 recurring can be 7/9. So any number that you can make a top and a bottom, that is rational numbers. All the integers also, because if you have 3, you can put 3/1. Okay. Can be negative or it can be positive. Irrational numbers cannot be written as an exact vulgar fraction. So if you go and press on your calculator square root 3, you get 1.732050808, and it just stopped because there's no more space on the calculator. It's actually just going on. Now you don't know, must I put it over 1 0 or must I put it over 4 zeros or 5 zeros? It don't stop. So I cannot put it a top and a bottom fraction. Okay, make it a fraction. And then numbers, so you can test all this. If it was a square, you cannot get a negative. That is imaginary, not real. But remember, you can get a negative cube root number. Okay, and then pi is not 22. 22/7 was the one that you used in primary school, but it's just an approximation. They just made it a rational number to help you a little bit with the calculations, because there you could not use a calculator. Okay, again, if you don't stop, then it's irrational. Okay, so with that in mind, I go back to the question paper. Okay. Now, very important, and actually I did this one. Can you remember? Because it was 0.777 going on. If it's the same number that's repeating, you can make it a vulgar fraction. If you can make it a vulgar fraction, it's rational. Write the word out. Don't make a short form. Write rational. Okay, square root 5 minus square root 5, okay, is what? It's going to be 0. So 0 is 0/1. That's also rational. I can make it a fraction, vulgar fraction. Now, square root 5 plus square root 5, press on your calculator. Calculator will always help you. Square root 5 plus square root 5. I get 4,47, okay, I can write it here. It's 4,472135,955, and it just stopped because there's no more space on the calculator. So sorry, this will be irrational. And check at the spelling. I'm also, if it comes to spelling, I must always check, because it's so, if I'm fast, I make unnecessary mistake. So write it correctly. Okay. And then this one, square root 5 divide. So if I square root 5 divide, and you already know it's 1. Okay. But remember, 1, can you put 1/1? Then it's going to be rational. Okay, and then square root 5, and you know that actually, because that's going to be 5, but press it on your calculator. Square root 5 times square root 5, and that is going to be 5, and you can make it 5/1. So that's also going to be rational. I think this was a nice question to really make sure that you know the difference between rational and irrational. So rational, for 1, if you write it correctly. You get already 5 marks. It's a lot. Okay. Let's go to question number 2. Okay. The formula, and they gave you the formula, it's an equation, is used in science. Work out V, and now it's basically just substitution. But I want to show you where it is in the textbook. In the textbook, you will find it on page, and there I'll show you the page. Do you see page 167? There is page 167. It's chapter 4, it's equations, there's an equal sign, and it's substitute numbers for words and letters in formula. And you can just check. So they will give you the formula, and then they give you the values. And I just always say, put it in brackets. So in U, put 10, because U is 10. In T, in brackets 2. And then just recopy, plus a half. Then in A, in brackets 5, T in brackets 2, and then you start. And then just do one term. So 10 times 2 is 20, and if I multiply 10, and then I will get 30. Okay, I'll just do that one. Just wanted to show you in the textbook on page 167, part 1 textbook. Okay, let's go back to the question paper. There is the question paper and there is the question. Okay, so I always write down first the formula. Okay, so what is the formula? It's U plus AT. And then in the place of U, I put 8. And I prefer brackets, especially if it's negative. And if the A, it's negative 10. And in the place of T, 7. And that will be 8. And this is going to be negative 70. Okay. And if I simplify and press it on you, if you cannot work with negative numbers or you still struggle with it, you have a calculator. Press 8 minus 70 because you must subtract and keep the sign in front of the big number. So it's negative 62. So V is equal to negative 62. Again, you will get 1 mark for doing that nice substitution and 1 mark. So just by putting it there into the formula, you're already going to score 1 mark, even if your answer is incorrect. So show your methods. And then make A the subject of the formula. I want to show you, it's also important in science, physical science and subjects like that. Right, so let's just go, I have for you there. And it's on page 169 in part 1 textbook, changing the subject of the formula. And if I look at this one, I think I'm going to do this 50. It's going to help you. So let's just look. I think I did it already a few times when I was doing the other question papers also. Now, it depends. If I must make D, put your focus there. Now, if that D was positive, I would have just left it there, that term. But because it's negative, I don't like working with negative. So I already jumped that one over. And the sign changed from a negative to a positive. The E is there. You can first do that. And now in the next step, because it's one thing which I usually tell learners, is don't do too many things in one step, especially if you struggle with it. So I just first did this. Now I'm going to take this E and I'm jumping to the other side because I'm trying, my whole purpose is to get this D alone on this side. Okay. And now I'm just going to, I don't want 3D, I want 1D. So I divide 3, and there is my, you can go and say 9 over 3 minus E over 3, but that is really not necessary. You can just stop there. Okay. So this was, and I'll just repeat, this was in the textbook on page 169. So if you struggle, do that, try now 50, just to help you. They love asking this. Okay. So let's go back to the question paper. And we're going to be here and we're going to do it. So again, I like rewriting it for my, so that it's almost like I zoom in. Okay. And who must become the subject? It's A. Now in this case, I'm not going to jump it over because it's positive. So I'm going to leave it there. I would rather take the U over. So I take the U over and I have 80. Because it's positive, I leave it there. And now who must become A? So I divide T. And now you can swap. So basically you are having, and I'm doing now long steps, but it's just maybe to help you. And now I swap the two sides and I have A. Just basically take the A, write it on, take that one, write it on that side. And that's going to be V minus U over T. Okay, I just want to see if they were taking, yes, they gave you again as a formula for, as soon they gave you 1 mark if you were doing this first step, and then 1 for your final answer. And that was the first paper of the question paper. Let's go to the next one. Question number 3. The dimensions of the cuboid shown below are given correct to 1 decimal place. Let's just underline that. Okay. Find the minimum volume of the cuboid. So limits of accuracy. Now, if I go to limits of accuracy, and now this is 1, 2, 3 values, because how do I calculate volume? It's length times breadth times height. But that's not what I must do. I must find upper, lower bounds, and it's a multiplication. There's a few things I must take into consideration. So let's just go first to that first question, to this summary. And I did it in the previous question paper, and I want to do it again because this is very, very important. And it's almost like it's the same with proportion. It's the two extended things was proportion in chapter 1 and limits of accuracy, and they are going to test that. So spend a little bit time on this. It's not that difficult. Okay. So let's just start with this table. Two approximated numbers calculate. So if there's one number, it's not a problem. As soon as there's two or three numbers, then there's things coming in. So if I want to show you this table, so if it's addition, then okay, so you can go and you find, okay, they say for example, this was 6 each to the nearest centimeter. So it's 1 divided 2 at 0.5. So to get the upper, I add 0.5. To get the lower, I subtract 0.5. And I do it for both. Now there's the four options. So if I say upper plus upper, and then I start upper plus lower, lower plus upper. I'm testing all the options. And then lower times lower. So if I'm looking at all these options, let me just get I see that this is the biggest one, 9. The 8 is in between, not big. I'm looking for extreme. I'm looking for limits. And I'm looking for the smallest one. So to get the biggest one, I basically said, and this you must see, and I'm going to use this. I want you to see that I was using upper plus upper and lower plus lower. Okay, that is for addition. Did you see that? Let's do the next one, subtraction. Now we do exactly the same. It's a test. This table is to show you practically how it came to. So there I just wanted to show you, I didn't maybe. So this is why, oh sorry, it's my pen I'm looking for. Okay. So the smallest here and the biggest there. No subtraction. So what are the lower and the upper bounds between the measures this? Now, if the difference, I do exactly. I take the big number minus the small number. And I start with, can I just show you here? Upper minus lower. Okay. Lower minus upper. I do the, okay. And then lower minus lower. Now again, I want you to focus. I want you to zoom in. Now, if you look here, you will see that the biggest answer, and I don't want blue, I want red. The biggest answer I got when I took the upper minus the lower, opposite, upper, lower. It was a combination. And the smallest answer was also a combination, lower, upper. Okay, and the 4 was just in between. But remember, limits, I'm looking for big and I look for the smallest. So that is why if I come to this, and I want to show you. So if I want to find this biggest answer, it's upper minus lower. So for the biggest, and remember biggest is meaning upper, the biggest upper, start with upper. And for the smallest, I start with the lowest upper. And this is what I showed you there. Okay, so for the lower, because we write always the lower bound or the smallest one there, and the upper bound, the biggest one, we write there. Okay, so basically that is how I do that. And now multiplication. So let's just see. I do exactly the same, exactly what I did. Okay, so now I'm just going to see again. Oh, this is my biggest. Oh, this is my, and if I look again, I see, oh, it's upper, upper. Just like, and oh, I want to yellow. Upper, upper, lower. This one looks, the multiplication is actually looking the same as the addition. Do you see that? Okay, when it's the same, upper, upper, same, lower, lower. Okay, so basically there I showed you that. I just want to get that, and I showed you that. Okay, and that's for the product. And then the last one, division. Now, again, I want to show you. So let me just, now I'm at division. So again, I want to show you this first. Do you see? Again, my biggest. Oh, now I'm in white. I want to be in red and I want to have a pen. This is my biggest and this is my smallest. Okay. So if you look again, you'll see, oh, this is the when it's opposite combinations, when it's upper, lower, lower, upper. And it's exactly, and this is why I was keeping my colors the same. If I want the lowest, okay, let's just make a pen. If I want the lowest, the smallest, that is actually just saying the smallest. That's the upper, that's saying the biggest. So this is going to be, if I want the upper, I start with upper, but I take the other one. And if I want the smallest, I start with and I take the other one. Do you see that? So what I want you to see before I start with the sums, because I'm going to focus on this, I just want you to see that addition, it's almost like these two are friends. These two, addition, and I don't want to use, I want to use yellow. Addition and multiplication, they are friends, or let's rather make them blue. Addition and multiplication are friends. And subtraction and division, they are friends. So you, even if it's a practical sum, you must just decide, am I playing addition, am I playing subtraction, multiplication, division, and then I follow the rules. And that's what I showed you there. And then I will go back to an example in the textbook. I don't know if I showed you that page, but that page was, I'm just going to tell you, it was on page 28. 28, just remember that. And this one is on page, that's summary. This one is on page 31. And this one, although it's just two values, it's just showing the principle. Okay, example 25. So I say calculate the upper and lower bounds for the perimeter. Perimeter. Now what is perimeter? It's 2 length plus 2 breadth of the rectangle shown if its dimension is correct to 2 decimal places. Just remember, if the perimeter is 2 length plus, so I'm playing addition, do you see? But first, before you do addition, you first get the upper, lower. So you take the two values. Where is my two values? I just want to take it, the two values. You can even, I'm going to write a little bit extra. So for this one, because it's 2 decimal places, it's 0.01. Divide 2, it's 0.0. That's what I'm going to add or subtract. So this one is going, the upper bound is going to be 4.845. And the lower bound is going to be 4.835. Do you see that? And then this one, the upper bound is 2.0, just that point, 2.005, and the lower bound is, so you just take 2 and you subtract that 0.05. So it's 1.995. You can do it on your calculator. Okay, now because we are playing addition, so if I'm asking you calculate the upper and lower bounds, I want the biggest and the smallest. So I want for the perimeter the smallest, and I want for the perimeter the biggest. And remember, because we play addition, that's why for the smallest we will put in all the small things. So we will go, and so for let me just show you. So I will take that one. Do you see? That's the lower bound. And I will take this one, and that's also the lower bound. Do you see? That's what I took there. And then for the upper bound, that was the upper bound. So it's upper plus upper, upper plus upper. But now it's just 2 because there's 2 lengths. Okay. So for the upper, I'm just taking this. So it's just take there. Do you see 4.845? 2.05. Okay. And that's what I do. And then I got my answers. I got my, do you see here? There is my smallest possible answer. And there was my biggest, that was that one. And there was my biggest possible answer. And it was, where is it? And the upper bound of the perimeter is 15.51. I just want to quickly test. Sorry, I'm just testing because I just want to see why that one, because that's perimeter and the upper bound, why that 2 is different. Maybe I already changed it in another textbook, in my latest textbook. Okay, let's just see. So it was 4.845 times 2 plus bracket 2 times 2.005 close the bracket equals 13.7. Looks like a printing mistake. There must be 13.7. I will check if I was changing it in one of the latest, because usually as soon as I print and I pick up a mistake, then I correct it. Okay, now we can go to that question paper. Okay, let's do it. Luckily, I'll say a few things. So in this case, before you start, if they say 1 decimal place, then it's 0.1 divide 2. So it's 0.05. So I'm going to add 0.05 to get my upper bounds. And to get my lower bounds, I'm going to subtract 0.05. Okay, so I can first take my free values. It's 6.22, 9.3, 3.1. And I can first go, and I like to just do it like this. This is upper, this is lower. This is upper, this is lower. This is upper, and this is lower. So I'm taking 6.2 and I add 0.6, then I'm going to get 6.25. I do the same, I subtract 6.15. I add 9.35. I subtract 9.25. I add 3.15 and I 3.05. Okay, and now to get that volume, now don't forget, what is volume? Volume is length times breadth times height. So I'm going to take you back because the page, I wanted you to see that page. I'm taking you back to this one. I'm spending a little bit time on this because I really don't want you to conquer this. So page 28. Do you see I'm here at multiplication? There I am. So to get the biggest possible, it will always be upper times upper times upper if there's another one. And to get the smallest, it's lower times lower times lower. And that is on page 28. So let's just go back to the question paper. And that was here. Okay. And then I'm just going to say, okay, so for they just ask the minimum. Make sure, I want to underline it. So they want the volume, they want the lowest bound. So it will be the lower times this lower times this lower. So it will be this one times this one times this one. Just the lowers. If they wanted the uppers, yes, do both, but they just want lowers. So it's 6.15 times 9.25 times 3.05. Okay. Maybe I just swapped this. I think this was the length and this was the breadth, but it doesn't matter. And don't forget what they told you, full calculator display. So 6.15 times 9.25 times 3.05, and I get 173.506875, and that's what they said, and I'm going to read it again to you. They want you not to approximate here. They said in the report, they said, however, candidates are advised not to round off their answers for questions on limits of accuracy. This is limits of accuracy. They should write their full calculator display. Okay, so please take note of that.